Hey guys, all right. Let's continue with our skill of composition of functions. Okay. Last time we completed examples 5 review questions. We tried example 6, 7, and then I asked you to try this on your own and with an understanding that I will be checking your answers, or actually the other way around, you will be checking your answers with me during this video note. So here are the answers and the work. Let me know if I accidentally did something wrong, okay? And I need to fix something really quickly here because one of you sent me an email saying that I got this one wrong. So this should have been a 2, okay? The reason that 2 divided by 2 is not 2, 2 divided by 2 is 1. So this is 1, absolute value of negative 2 here. It's sometimes it lets me write and sometimes it doesn't, equals a positive 2. So the final answer is positive 2. Given f of x equals 2x squared minus x plus 4, and g of x equals 3 divided by x minus 5, we have 4 examples here. It says compose, example 14, find f of g. So as you can see, there's no f of g of 1 or there's no f of g of 5. So what this means is that it's f of g of x. Okay, so this means f of g of x. Okay, so, well, inner component, it's already g of x. Well, g of x is this guy's right here. So we are going to take g of x and put in 3 divided by x minus 5. So what we're really now computing is a new function using f. So we are now, every time we see an x in f, we will plug in 3 divided by x minus 5. So I see first x is a square, I see another x, and then I see a 4, which is not an x, so I'm just going to copy that down. So every time I see an x, I now plug in x minus 5. And I will now slowly write it out twice so I can FOIL. And this just requires very cautious algebra work. So write this out twice so we can start foiling. Okay. This one I will keep it as is for now and then bring down the 4. So from here, I'm gonna do the 2 after. This is 3 times 3 on the top is 9. FOIL the denominator, so that's x squared minus 5x minus 5x plus 25, and then drop everything else down for now. This will give me 18, right? All over. Well, even if I FOIL, as you can see, even if I FOIL, it doesn't really help me reduce. So technically, we didn't have to FOIL that, but I guess we can just find a common denominator. So LCD, well, let me go back and unfoil this denominator and just write it as a quantity of second power. Okay. All right. So what we want to do now is find the LCD, which we all know how to do. It's going to be x minus 5 quantity square because this has a higher power, and then I'm just going to write the 4 in the front. That means each and every term gets the same LCD. Each and every term gets the same LCD. Okay. All right, so now we need to decide what's missing, and I'm going to find the highlighter. So this is my first denominator. Here's my change denominator. That means the numerator gets multiplied by 4. Next, this is my first denominator. This is my change denominator. So that means the numerator gets multiplied by 4 and an extra set of x minus 5. Then the last one has no denominator at all except a 1. So now I need to multiply this 4 by the quantity of x minus 5. Oops, sorry. Go and add this for me, a square. I need to multiply by an x minus 5 quantity square. So now we are going to see if we can combine the numerator. So all of these are now can be placed over one common denominator. Then what you want to do is multiply it out. 18 times 5, that's going to give us, not 5, I'm sorry, 18 times 4, that's going to give us 72. That's my first numerator. Then we want to distribute the 3 times 4, which is 12. So minus 12x. And this is a negative 12. So we're going to see that if negative 12 times x is negative 12x, but negative 12 times a negative 5 is now going to be a positive 60. Then the last thing over here, remember we already distributed the x minus 5 from here, the quantity of that. So I'm just going to copy that over. So that's going to be an x squared minus 10x plus 25. Next step is going to see if we can combine some like terms, which I can. 72 and 60. That will give me a 12 on the numerator minus 12x. And now I'm going to distribute this 4 throughout. So 4x squared minus 40x and then plus 100 all over the LCD. Okay. Now if you can, write it small so you can fit it all in. Whoops. Okay, so from here, I'm going to write it in standard form. That means the highest degree first. So that's 4x squared, negative 12x, and a minus 40x is negative 52x. Okay, there you go. Finally, it's coming up. And then 12 plus 100. Oops, what happened? Negative? No, there you go. Okay, negative 52x. And then plus 112 all over 4 times a quantity. Now, you always want to see if you can factor out. If you can factor out 4, then you can reduce with the denominator of 4. So we want to see if 52 is divisible by 4, which is 13. 112 divided by 4 by 28. So our next job is take out the 4. So you have an x squared minus 13x and plus 28 all over 4 times x minus 5 quantity squared. Well, these two can be reduced. Then that means now I want to see if that trinomial on the numerator is factorable. So on the top is 28, on the denominator is 13. Can I find two numbers, multiply, give me 28, and add, give me negative 13? 28 is going to be what? 4 times 7. That's not going to give me 13. And then 28 is what? 2 times 14. That's not going to give me negative 13. 28 is going to be, so we did the 2, we did the 4. Anything else that we can use for 28? That's it. So I don't think I can find two factors. Multiply gave me 28 and add gave me 13. So it's not factorable on the numerator. So that means I can just box up my leftover. So the leftover, which let's go back to see what we were doing. We were trying to do the composition of f composed with g. So f composed with g is x squared minus 13x plus 28 all over x minus 5 quantity square. You can box that up, okay, just like that. Now, if you distribute the bottom and you want to write the bottom out, that's okay too. You can write the bottom earlier. It was x squared minus 10x plus 25. Either one will be acceptable. So I know this one has fractions, which will require you to go back and remember how to add fractions. So make sure we pause, rewind if you don't remember how, and take really great notes, okay? Let's try another one, 15. 15, for this one, I'm asking you to do f of I'm sorry, not f, g of f. Okay, so let's get a different color. And there you go. Okay, so g of f, meaning that the f of x is now the input. So this is now f of x was 2x squared minus x plus 4. That means every time I see an x in the g function with there's only one x, which is right there, and I'm going to drop the negative 5 down. Since I only see one x, every time I see that one x, I write in this entire thing, 2x squared minus x plus 4. Then from here, what you want to do is combine like terms. That will give us 2x squared minus x minus 1. Then we want to see if we can factor and reduce. Even if I can factor, I can't reduce. So that is as far as we can go with the composition of g of f. So 3 divided by 2x squared minus x minus 1. Box it up or highlight your answer. Since I have a highlighter, that's what I will do. Next is similar, except that now we are trying to do f of f. By definition, it's f of x. What that means is the f of x is also the input, so 2x squared minus x plus 4. Well, the f function has 2 x's, so I would need 2 different blank spaces. Every time, again, I see a x, I have to enter all of that in. And I do it twice because the f function has 2 x variables. Okay. Then from here, slowly and carefully distribute this guy. I'm going to write this out twice and distribute. So that's 2x squared minus x plus 4. 2x squared minus x plus 4. The next is I'm going to distribute all the negative sign here. That means all of this will change. Oh, look, the 4 will cancel each other out. Okay. All right. Now, here's the part where we have to slowly work this out. I'm going to do a big bracket here because I'm going to need a lot of space. Ready? Different color. 2x squared times 2x squared, that will give me 4x to the 4th. 2x squared times a negative x, it would be negative 2x to the 3rd. 2x squared times positive 4, that's going to give me positive 8x squared. Next is going to be a different color. Negative x times 2x is now negative 2x to the 3rd. Negative x times a negative x is now a positive x squared. Negative x times a positive 4 is now a negative 4x. Let's get a different color. Yep. Last term, 4 times 2x squared is now a positive 4x squared. 4 times x is going to be a positive, nope, 4 times negative x, my bad. 4 times negative x is negative 4x. And 4 times 4 is now a positive 16. Okay, these two can be reduced. I'm just going to be now dropping these 2 terms on the back down. What do I do with all of those inside? I'm going to combine like terms by adding it vertically. That means straight down. I only have 4x to the 4th minus 4x to the 3rd. That's going to give me 13x squared, negative 8x, and a positive 16. Drop these 2 guys here in the back down. And from here, distribute the 2. 8x to the 4th minus 4x. Nope, not 4. I need to distribute the 2. 8x to the 3rd plus 26x squared minus 16x plus 32. And then drop these 2 guys down because we are about to combine like terms. Since we only have 1x to the 4th, I'm sorry, 1 term of x to the 4th, I can easily just drop these down. I do have 2 terms of the x squared, so that will give me a positive Now 24x squared. I do have two terms of the x's, so that will give me a negative 15x and drop down my 32. Now this answer is the answer to f of f. So now I can highlight that or box that all up. No, you don't need to factor it out because it's not a fraction. So even if I factor it out, I'm not going to reduce any further. So when you have a polynomial, try to combine like terms and then you can leave it. Okay. Last example on this set is going to be g of g, which I am now going to do it all the way over here. So g of g, meaning that is g quantity g of x. That means the inner component, it's itself, so which is 3 divided by x minus 5. So 3 divided by x minus 5. Well, luckily, there's only one x location, and every time I see that x location, I have to plug in 3 divided by x minus 5. And we have done these type of questions before where we now write it as a division problem and try to find the LCD. Okay, minus 5, this is minus 5 of the 1. LCD would be x minus 5. So what we can do is multiply this by x minus 5, multiply this by x minus 5. Then this will allow us to write 3 divided by the denominator are now exactly the same. So now we go 3 minus 5x plus 25 because we have to distribute this negative 5 to both. Then from here we go 3 divided by the numerator. I will write it in standard form. Okay. Then because we are dividing, we can technically write 3 over 1 if you like. If we are dividing, we can multiply by its reciprocal, just like this. Then distribute the numerator out. So this is going to be, or you don't have to distribute the numerator. We can leave it because you can see that it's not going to help us reduce. But I do want to take out the negative 1 on the bottom because it's not really pretty having that negative 1 on the bottom. If I take out the negative 1, we now have a negative 3 on the top because 3 divided by negative 1 is now negative 3 on the top. And that's the only thing that's really changing. Okay. Now, if you don't want to assign that negative 3 to the numerator, that's okay too. You can put it in the bottom. You can put it in front of the division bar. But usually the denominator, we want to make it pretty by moving it to the top or in front of the division bar. Okay, so again, if this is going too fast, I do need you to pause it or rewind and then watch it again. So those are the examples 14, 15, and 16. 14, 15, 16, and 17. Okay, now we have one last check for understanding here. This again, check for understanding is supposed to be when you do it, and then the next video we will check it again. Okay.